The house is burning, but we're still sitting in the glow. Phones charged, lights on, pretending we don't know. But the forest is silent, the river's running low, and the flame on our plates is the strongest fire we throw. Put out the fire, put out the fire. Echoes and rise, this is your hour. 7 boundaries broken, the earth pushed past the line. Climate, land, species, fresh water, chemicals, nutrients, oceans in decline. Not danger, disaster in real time. Put out the fire, put out the fire. Metafoodians rise, this is your power. And here in India, one truth stands the same. Milk is not just milk, dairy feeds the flame. Cows and methane, fields and forests turn to grain. Politics, culture, carbon, all wired to the same chain. Every cup of curd is heat in the air, every block of butter is a forest repair. It's not a small habit, it's a planetary affair. Put out the fire, put out the fire. Echoes and rise, this is our hour. Energy fixes half the hurt, Dr. Rao made that clear. But food fixes the other half, the half that's burning here. Change the plate, change the land, change the future's atmosphere. Put out the fire, put out the fire. Metafoodians unite, this is your choir. Every millet, every fruit, every sapseed, every bean is water on the wildfire of a world we've never seen. Every oil-free bite is a river turning clean. This is not perfection, it's direction. Not pressure, but protection. A week of choices can cool a generation. A company's courage can ignite a nation. Put out the fire, put out the fire. Echoes and rise, this is your hour. Metafoodians unite, Metafoodians ignite, sharing love in the metazone, light in the path to a cooler home. Put out the fire, put out the fire. Together we rise, together we inspire.
Welcome to the Planet B podcast, where truth, transformation, and faith converge. Join us as we flip the script on ecological despair, guided by Dr. Sailesh Rao's vision for a compassionate, rewilded vegan world. Let's begin the journey to the greatest transformation in human history.
Welcome to episode 11 of the Planet B podcast. Today, we're going to take an in-depth look at setting context in time. Dr. Rao, we're welcome to have you once again.
Well, thank you for having me. Thank you for this opportunity to speak to all of you.
Oh, it's been so fun, and we hope people have enjoyed the first 10 episodes. And here we go into a little bit of the history of how human beings have played this integral role with nature over time. So, Dr. Rao, would you like to start with the opening quote of chapter 11?
Yeah, it's a quote is from Father Thomas Berry, and he said, "The earth is not part of the human story. The human story is part of the earth's story." The problem is we have tried to tell the human story without telling the earth's story. And to tell the earth's story, you have to tell the sun's story. So it's like the sun is not part of the earth's story. The earth's story is part of the sun's story. We have been trying to tell stories backwards. When you go the other way and you start telling the story as if the earth is part of the solar system, the sun is part of the Milky Way galaxy, and humans are part of the earth. So then you see the human story within the earth story, and you see the earth story within the sun story, and you see the sun story within the Milky Way galaxy story. And then everything makes sense. You begin to understand our role, you begin to understand why we have to play this role at this time, and we understand why the earth wanted us as a species to play this role right now.
That's beautiful. So can you share more about the scientific evidence that humans have been an integral part of nature for thousands and thousands of years of Earth's history?
Yeah, I begin with yoga, right? So yoga is a spiritual way of looking at things. It says that separation is a delusion. Yoga is unity, right? It's about union. It begins with the presumption that separation is the delusion. You have never been separate from nature. You have always been a part of nature. Okay? And that is factually true, because we breathe in air that the trees breathe out. So we are so intimately connected with the rest of the world, rest of nature, that if that nature goes away, like you suddenly someone drops you off on Mars, you say, wait a minute, where's my oxygen? Where's my food? Because all that we were getting from nature here on Earth. So understanding that moment by moment, that you have always been a part of nature, you're always a part of nature. And you know that that is scientifically valid, just from the input-output of human beings, and our systems. And then you try to place that within the context of nature, and then place nature within the context of the sun and what is happening to the sun. The sun is going through atomic reactions on the surface. There's lots of nuclear fusion happening, and things are getting warmer and warmer over time. This is how a star like that behaves, right? We know that from science. And as the sun gets warmer and warmer, the habitable zone around the sun keeps moving out further and further. But the Earth is in a constant orbit. It doesn't change its orbits quickly, right? So which means the habitable zone is moving further and further out, and the Earth is getting closer and closer to the inner edge of the habitable zone. A habitable zone is a zone where liquid water is found on the surface of a planet. Mm-hmm. So there are models for saying, okay, where will the habitable zone be? And so these models are telling us that we are very, very close to the inner edge of the habitable zone around the sun. So which means that life is getting more and more complex. Life has to become more and more complex to adapt to the more and more stringent environmental conditions for life to thrive. And we are part of that complexity that life is calling for in order to maintain its well-being. So life always wants to thrive. So we have to begin with that, right? So what is life? Life wants to live.
Yeah.
Right? We are just part of this major nature that is life. As a part of that, we are creating that complexity to help nature thrive at the inner edge of the habitable zone around the sun. And that's what my research findings are telling me. And I tried to tell the human story as part of the Earth's story, and the Earth's story as part of the sun's story. The sun is just one ordinary star among, billions of stars in our galaxy. And the sun is going around the black hole at the center of the Milky Way galaxy. It goes around once every 280 million years.
Wow. That's crazy.
That's the sun's year.
So as the Earth gets closer to the edge of the habitable zone, then essentially because we're closer to the sun, it would become warmer, just in general over
Right,
time.
right. And you would think it's going to get warmer. But the way this system operates, greenhouse gases are creating the blanket for life to thrive. Because there were no greenhouse gases, the estimate is that the Earth's surface temperature will be 60 degrees cooler than it is today. So it will be frozen solid if there were no greenhouse gases. So you don't get that much sun, you know. But because with the greenhouse gases, it's maintaining that liquid water on the surface. Now, as the sun gets warmer and warmer, the greenhouse gas blanket got thinner and thinner. And you see that in the record as well. It gets thinner and thinner. And there is a strong correlation between temperature and CO2, even in the fossil record.
Mm.
Okay, CO2 is the main greenhouse gas. And now, over the last 3 million years, the CO2 levels have been going between 180 parts per million and 280 parts per million. So, which means that the CO2 level got to be so low that it's now very sensitive to small changes in the sunlight that's coming on Earth. And it goes and triggers between these two stable states. One is the glaciation, and there's a warm period between glaciation. So it's called the interglacial periods. So it's been doing that for the last 3 million years. Most of the time, the Earth was in a glaciation. We are in an ice age right now.
Which is crazy to think about.
Yeah, we are in an ice age. We are in the interglacial period between two glaciations.
Hmm.
But in this interglacial period, human beings have prevented the Earth from going back to glaciation 5,000 years ago. We did that by just burning down forests, using fire to heat up the planet.
All right.
Okay. And now we have been given the opportunity to stabilize it and maintain it so that the Earth does not ever have to go back to glaciation again. So Earth is now very sensitive to slight variations in the sunlight that comes down to Earth. She's asking us as a species to actively maintain the temperature on Earth at this stable state. Okay? That's what we are understanding that we have to do.
Right.
And then the Earth will not go back to glaciation again, because glaciation, the CO2 levels are 180 parts per million, so in the atmosphere, which means that life does not thrive. Literally, life becomes confined to the equator. All the rest becomes frozen solid. But then again, if you heat it up beyond this, so we have heated it up by 1.5 degrees Celsius compared to what it was 200 years ago. If you heat it up, it's not clear that there is another stable state. I mean, you cannot judge that based on what happened 500 million years ago or 200 million years ago, because the sun was different then. So you have to understand that the dynamics of the system that we are in. It's not about saying, oh, it was stable then, because when you say it was stable with a CO2 level of 1,000 parts per million, 50 million years ago, well, it was a different sun then.
Right.
So when you make a statement like that, you are saying the sun has not changed. Okay? And then simultaneously you make a statement that the sun has changed and that's why the temperature is increasing. So people say these inconsistent things. And I'm saying your story has to be consistent when you do systems analysis. So systems analysis is telling us that as the sun changed, the sun got warmer and warmer, the Earth basically reduced its CO2 levels until it got to a point where it was so sensitive, it was toggling between two states. Okay, and now it's using us to stabilize it. And once we join the Earth and and understand that we are part of Earth and we've always been part of Earth and we have a role to play, then we can hopefully maintain this for the next few 100 million years as the sun gets slightly warmer. It's going to get like 1% warmer every 100 million years.
Right. So essentially, that means that over the last few thousand years, humanity has played that vital role in actually warming the planet to then give it the opportunity to create a stable state.
Correct, yeah. To maintain that stable state, to stay there in that stable state instead of going back down.
But
As
now we
this,
must flip the script, we say. We can't keep warming.
yeah, you cannot keep warming it. You have to start cooling and stabilizing it. So,
Right.
stability is what we want, right? Stability is good for life. Stability of the conditions, right?
Right.
Like it's like having an AC in your home, you know. So the earth is saying, create a thermostat so that you can maintain it forever.
That makes a lot of sense. So then, something that you talk about that's really interesting that some people maybe don't know is this relationship between the CO2 and the water vapor from the soil and how that creates this blanket around the earth. Could you share a little bit more about that?
Yeah, the CO2 is like a catalyst for water vapor. So water vapor is the main heating gas. Water vapor can both cool or heat, okay, depending on whether it is condensed as cloud, in which case it can reflect sunlight back, or it can be a greenhouse gas and it can reflect infrared energy back down to the earth. But water vapor is temporary, whereas CO2 stays there permanently, right? So the CO2 does the initial warming permanently because it's there permanently, and then it gets water vapor to evaporate from the ocean or from rivers or from trees. Yeah. And that water vapor then does the amplification of the heating. So think of it as like the anode and the cathode of a battery, right? If you don't have those two things, you don't get electric current.
Right.
So if you say the electric current is caused by the fluid inside the battery, therefore I don't need these little things that are sticking in there, and you take it out, the battery doesn't work. Right? You have to have that catalyst. And CO2 is the catalyst that causes water vapor to be in the atmosphere and therefore heat up the earth.
Mm.
So other greenhouse gases are also catalysts like that. They also amplify through water vapor, like methane does that. All of them, all the greenhouse gases do that. And cooling effects are all caused by molecules that reflect sunlight back within the visible region.
Chapter clearly illustrates is when we set context in time, it shows the scientific evidence of how humanity has played this vital role in getting to this critical point where we can stabilize Earth systems. So what are the things that we need to change to move into Planet B where we can help become part of this stable state for hopefully hundreds of thousands of years to come?
Setting the context in where we are today is an interglacial period within an ice age, which most people don't even realize we are in an ice
Right.
age, right? And that ice age came about because the Earth's natural mechanisms for stabilizing the climate are no longer able to handle these variations. Like the natural mechanism is rock weathering, which has very large time constants. So those things happen over 100,000 years. Whereas we are able to change things within hundreds of years. So we create fast feedback. And therefore we can now stabilize the climate much more effectively than rock weathering and mechanisms like that. So we have to consciously do it. Right? And so setting the context of the human story within the Earth's story, how the Earth is now in the inner edge of the habitable zone, and within the sun's story, how the sun always gets warmer slowly over time because of nuclear reactions. And the sun is, going around the Milky Way's black hole once every 280 million years. So it's a very critical time in the Earth's history. Is the Earth going to survive and thrive for another 100 million years or no? Or maybe a billion years, who knows? Once we stabilize it and we hand it over to our children and grandchildren, we say, this is the story and you do whatever you want with this story. Okay, that's up to you. But we want to hand over a stable state. because we always wish that our next generation lives in a prosperous environment. That's what every parent wishes.
Yeah.
A brighter future for their children and grandchildren. And we have a responsibility to create that and then let them figure out how they want to maintain. Because who knows what's going to happen. Science will advance. We will know more. As we know more, we may have to do differently, whatever it is. But the intention has to be, we are here to serve all of life, and we are here to maintain prosperity for life.
Yeah, very beautiful. So Dr. Rao, as we wrap up episode 11, would you like to share any closing message with our audience today?
Basically, I'm an engineer who's trying to understand science. And I'm trying to tell this story from a scientific perspective. And then I realized that science and spirituality are coming together. This is a common story. So which means everyone is trying to align with the truth. And the truth is one, So thank you so much for being with us on this journey.
Awesome. Well, thank you so much. And please, everyone can download and read the book at climatehealers.org. The book title is There Is a Planet B. And we look forward to hopefully having you join us once again for episode 12, where we talk more about Quaternary Ice Age. So thank you so much for joining us, and we'll see you soon.
This is a podcast from Planet B, where kindness isn't a niche lifestyle. If you haven't moved here yet, we thank you for visiting.
Hello everyone. Let's open the floor for questions for the last few days. It doesn't have to be just for this episode. BJ, you have a question?
I wonder about the sun's instability that you referred to, and I'm wondering if it's just because we don't know how stable or unstable it is, or do we know that the sun is heating? But you said something about not counting on the sun, and that seems yeah.
No, actually, the sun is a relatively stable star from all our observations, and it behaves like other stars that we observe, right? And so based on the other stars, they're estimating that it roughly increases in intensity by 1% every 100 million years. Okay, that's the estimate. Now, we don't have any evidence to show that it could go suddenly crazy.
Oh, right, okay. So that's one of the stable things in our environment.
Correct, yeah. Relatively stable. Yeah. As I explained this morning, the glaciation and interglacial periods happen not because of the sun directly, it's because of the Earth's wobble in the orbit around the sun. These are known as Milankovitch cycles. And the Earth has slight wobbles that changes the profile it presents to the sun at different seasons. So that changes the average amount of energy that comes from the sun. And the estimate is roughly just 1 watt per square meter out of 130 watts per square meter. If it changes by 1 watt per square meter, it's enough to push it into a glaciation, and vice versa, comes out of glaciation. Now we have overwhelmed it, with human activities. We have increased it by 3 watts per square meter. So we have overwhelmed the natural variations due to the orbit around the sun. And therefore, Jim Hansen has said you will never go back another glaciation until humans disappear off the face of the earth. Because absent human activities, that can go back to glaciation again. But right now, there's no, as long as we are around, it's not going to happen. This is why I say we have been called to become the thermostat species. You know.
I love that. Thank you. Oops. I'm bringing her up.
Yeah. Go ahead.
All right. This is on another week. You mentioned 3 trillion trees. We need to plant 3 trillion trees, and I know that you want them planted where all the places where we used to have forests, where we used to have. Now, if people just say, "Oh, we'll just plant 3 trillion trees," or they don't intend to go vegan, they don't intend to do all these other things, and they just say, "We just need to plant 3 trillion trees." Where is there room to plant them? Are there places to plant them? That's what, without using the grassland, without using I'm trying to just get all the arguments that might come my way, and be prepared.
Right. Right. Now, see, from a systems perspective, I'm asking that we restore the system that used to be there 200 years ago as closely as possible, because I know that was a stable state. Just planting random trees all over the place, I don't know if that's going to be a stable state. You know what I mean?
Okay.
Yeah.
Makes
So
sense.
this is why I'm suggesting that we try to go back to what was there before 200 years ago, because it was a stable state in terms of not only biodiversity, all the other loops. So it's not just climate. We have to take care of all the loops that govern planet Earth's systems.
Okay.
And so there used to be 5 to 6 trillion trees on the planet. We need to restore them back, right? And mangroves and prairies, and there are lots of other ecosystems. So we have to try and bring them all back, because we are trying to restore the stable state that was there.
Okay, that sounds good. And I do have one more question, and it's when we talk about, and I did miss the first 5 minutes. You may have mentioned this in the first 5 minutes. Sorry, but if we bring down fossil fuels, I know you said that the planet could heat up a whole lot. When we bring down fossil fuels, are we bringing down 2 other cooling gases or 3 cooling gases along with it? Like, are they kind of joined? They're in the fossil fuels themselves?
Yeah, they're kind of coupled in. There are a lot of developed countries where they have put mechanisms in place to capture the aerosols, capture the sulfur dioxide, so that it doesn't go into the atmosphere. They did that it started in the US. Actually, my cousin's husband was one of the first engineers who worked on that.
Wow.
In a power plant here in the US in the 70s. And basically they did that in order to eliminate acid rain.
Okay.
Because if you put sulfur dioxide into the atmosphere, it comes down as sulfuric acid. And it was killing all the trees in the Adirondack Mountains in New York, right? So it was a good thing they did that. They did that in the 70s. But then you see the temperature going up. Starting in the 70s. If you look at the temperature record, it was kind of flat until the 70s, and then it starts going up. So the cooling effect disappeared, and basically the Earth started warming again, right? Warming. And then right now we are emitting a lot of fossil fuel based sulfur dioxide, mainly in developing countries or in poor countries, because they don't bother with capturing the sulfur, and they just burn it.
Okay.
Right. And it was also happening in ships.
Okay.
Right. And starting in 2021, the International Maritime Organization passed a decree that ships cannot burn what they used to call bunker fuel anymore. So they put a restriction on how much sulfur can be there in the fuel that ships burn. They lowered it from 3% to 1% or less, or something like that. Okay. And when they did that, the amount of sulfur above the ocean decreased.
Okay.
Sulfur dioxide above the ocean decreased. And the scientists had estimated, the International Maritime Organization, when it did that, it also had scientists calculate how much will that impact the temperature and how much will that impact the heating. And the scientists had estimated 0.14 watts of heating, okay, from that act. And they thought it was negligible compared to the rest, because we have 3 watts per square meter, so 0.14 watts is nothing. But it actually changed by 0.5 watts according to measurements. Our measurements are showing that it changed by a lot.
Yeah,
because you
okay.
can see the reflectivity above the ocean change a lot, and it changed by about 0.5 watts. So it's 3 times what they were estimating, 3 to 4 times what they were estimating, right? And so, and this is because the sulfur dioxide molecule over a pristine ocean is much more powerful than the same sulfur dioxide molecule emitted over land, where there's already a lot of pollutants.
Oh, okay.
So there's a highly nonlinear effect for introducing sulfur dioxide to a pristine atmosphere. Okay? And that's what we removed with the IMO decree. And this is why 2023 and 2024 and 2025 are the 3 hottest years ever. And they just stick out like a sore thumb. You know, if you look at the temperature record, they just stick out like a sore thumb. So, and that's because of the elimination of sulfur dioxide above the ocean. Okay. That's the explanation that Jim Hansen came up with, and he published it in March of this year, March of 2025.
Okay.
So this is all new science, you know, we are figuring it out. So it's as if we are running an experiment in our own home, and then we are verifying our theories.
Okay. All right. Well, thank you.
You're welcome. Maybe you got a lot more detail than you asked for.
I like detail.
Okay, good. Go ahead, Danny.
I wanted to know about solar flares and their effect on the Earth, what they are and how they affect the Earth and the climate, please.
Yeah, they're kind of known. So you see slight variations in the amount of sunlight that comes down to Earth based on solar flares. So, so they're all, I mean, this way all being constantly monitored and measured, and their impact is not as big as what we are doing.
Okay,
Yeah,
thank you.
I mean, I think we have orders of magnitude more impact than solar flares.
Okay, thank you.
But that doesn't mean, you know, it's possible that you could get a solar flare that just wipes out our magnetic field. And,
Yeah, I've heard
Yeah.
that. Thank you.
Yeah. Yeah, the impact of volcanoes is, I mean, you can see that in the Pinatubo record. So when the Pinatubo erupted, and you see sulfur, it emits a lot of sulfur dioxide and it cools. So you can see a cooling effect. And then as soon as the cooling disappears, you see an instant warming. You know, it's like it get a spike of warming. And so it's similar. So that's the kind of thing you should expect from a large volcanic eruption. But the volcanic eruptions that are happening these days, I mean today, you know, haven't had as much of an impact as human greenhouse gases. At least that's what the current theory is telling us. But as you can imagine, there are alternate theories that people have come up with. But the alternate theories are not widely accepted, mainly because they are not consistent. There are a lot of inconsistencies in the theories. Ultimately, it will be just like what happened with the International Maritime Organization's experiment. We try it, and then we realize, oh my God, we made a mistake, and then we realize that we have to update the theory based on that. But when we go vegan and we reforest the planet, we expect everything to get better. That's what the theory is telling us now.
Dr. Rao, what have we learned from the maritime experiments over? You told us some of the things that they learned, but why hasn't that been extrapolated into our other greenhouse gases? Into the other theories of, look what happened when we did that with the ships. Maybe we better pay attention to the rest of the earth.
Now again, you see an observation. So the decree happened in 2021, and then you observe that the temperature has increased dramatically in 2023, 2024, 2025. And Hansen is tying the two together, but not everybody is tying the two together. Because other people have other explanations for why it happened. So now the jury is out as to which theory matches better, right, with observations. Ultimately, observations are what the earth is telling us. This is what's going to happen to you if you did this. This is what happens to you. Now, what is the cause? What is the effect? That's up to us to figure it out. And I think Hansen's explanation makes a lot of sense, because he's basing it on observations of also the reflectivity above the ocean. He's showing that the reflectivity above the ocean decreased dramatically, and that's why, so now why did it decrease? Is it because of the lack of sulfur, or is some other reason? We don't know.
Okay, thank you.
Yeah. Go ahead, Brittany.
You were mentioning rewilding. I was kind of wondering how the renewable energy plays into the rewilding direction. I know that fossil fuels have a cooling effect on the planet, but I believe from what your graphs show, it has more of a heating effect than a cooling effect. It's just that there is some cooling effect that creates different numbers. So would it still be all right to seek out renewables for like a vegan rewilding direction? I know a lot of deforestation, the more I look at it, has to do with fossil fuels, because what's above the ground is the trees, and then once they cut down the trees, then they'll go for the coal underground. Yeah.
Mm-hmm. Yeah. No, I think the conversion to renewable energy infrastructure has to continue at the current pace. There's no question it has to, because it's not happening fast enough. The optimum rate at which we can reduce it to zero is around 30 years, according to my calculations. So we can reduce it to zero in about 30 years, but that means you have to go vegan first, right? We go vegan right away. So I'm saying to people who are pushing for fossil fuel conversion, please continue, don't change. But for heaven's sake, go vegan and promote veganism, because it's a critical first step. Yeah, in the conversion to a clean energy economy. I mean, we don't want to be burning stuff that that puts all kinds of aerosols into the atmosphere in the long term. Just for our
Yeah,
energy
I'm
use.
kind of like wondering, where do you feel like raw veganism fits into all this? Because we're thinking about, the context, then it's like a lot of the deforestation has to do with charcoal and wood for burning bioenergy, biomass. So I get that with animal products you have to cook a lot more, but do you think that the veganism is not enough if, say, we go in that direction because of the cooking skill involved, that we should do a little bit more?
Well, I think raw veganism as a global prescription will reduce the amount of food available to human beings considerably, because cooking allows us to access grains and root vegetables and things like that, which you won't get, so at the moment, I say don't do that. Don't say just go raw. I'm saying, cooking can also be done with clean energy, and let's transition. And as our population decreases over time, then you can think about those things.
Well, I think a lot of the, like, when you look at like fake meat, and there, I kind of see it as a byproduct of animal agriculture, and a lot of that needs to be cooked. In general, wheat, the faux products, they tend to get cooked. So maybe as we start rewilding, I kind of envision there's going to be more biodiversity of food, that
Right.
I don't really see a lack of it. And it's going to be more nutrient dense. So a lot of the main arguments is that it's not nutrient dense, so you have to cook it down, but that's because we might be eating the food of livestock feed, just given to humans. But as people start going in that vegan direction, we might not need to worry about it, but you still don't see it as part of the transition. That's something different.
No, I mean, eating more and more fresh fruits and vegetables is recommended, obviously. But do we completely eliminate cooking? That's, at least initially, I would say I won't push for that. At least I won't push for that from a systems angle. But over time, it could happen, right? Because obviously, if you don't have to cook, then you're saving so much energy, right?
Yeah, because I just would imagine it being a little more natural and kind of
Right.
connecting with being a part of nature. But yeah.
Right, absolutely. Yeah, you're returning back to the African roots of our African roots. Yeah.
There you go. I think Abraham had their hand up.
Yeah. Go ahead, Brown.
Yeah. What kind of trees do you think we should plant? Do we know the trees that were 10,000 years ago?
Oh, we know the trees that were there 200, 300 years ago, and when it was relatively stable. So I'm recommending planting the trees that used to be there 200, 300 years ago, because we have maps, we have fossil records, and based on that we have reconstructions of the kinds of forests that used to be there. Actually, we have it over time. It's called the history database of the environment. And so again, it's you're trying to restore the original forest. So you plant the trees that are native to that region, and then you see which animals are back, and which animals are not back. And if they're not back, you have to figure out what food they want to eat. It's really, because biodiversity loss, biosphere integrity is the worst transgression, our primary purpose right now should be to restore biosphere integrity. So to restore biosphere integrity, we have to make sure that the food is available for the animals that used to be there.
Yeah. Mhm. Yeah, there were also stories that some of the trees were releasing carbon dioxide rather than absorbing it. It's hard to understand, but do you agree
Oh,
with that? Some
no,
trees
no,
were.
I think the calculations are based on net emissions. Basically, the Amazon could become a net emitter if you
Yeah,
keep deforesting at some point, because then if you keep deforesting at some point, it's no longer a rainforest,
yeah.
it becomes a dry forest, and then it starts burning with lightning,
Hmm.
right? So then it's emitting more than it's sequestering.
Yeah. Oh,
Yeah.
okay. Thank you.
Sure thing.
Okay.
Go ahead, BJ.
Yeah, I was just going to also just kind of give my opinion a little bit about the raw vegan diet. And one of the problems is I think that a lot of people will go vegan and they'll try to do like an Esselstyn type vegan thing or a raw vegan thing, and then it's so different from what they're used to eating that then they just go off it. And so for me, I kind of feel like it's sort of good that we have some of those processed foods out there so that people can still, though they can be off all the animal agriculture, but they could be eating, say, the vegan cream cheese and all of that. And then after a while, they'll get more used to, okay, let me try these legumes. Yeah, I didn't know what a legume was, and things like that. Because even me now, I will still eat processed cereal, but it'll be whole grain, because I was raised on it, and I'm kind of like a person that has safe foods. I think it's
Right.
called when you're kind of a little wacky in the brain, and it's like, it's like I have to have that food. But like I'll eat oatmeal for lunch, but I won't eat it for breakfast. This is sort of weird, but because I just don't want anything to be too limiting, because then people won't join. Um, like the sweet potatoes on everything for color. It's like I was like, why does everything look like it's got sweet potatoes and avocados? And it's like I'm not going to eat that. And leaves on their pizzas. Why do they have leaves on their pizzas? I just remember all the things I went through, and so I was happy to have um, pasta and vegan Parmesan cheese, and I slowly got off all those. It's like we make changes as we go along, and then also in a few years we're going to be having like that precision microbial fermentation, where everybody's going to have a little microbial brewery in each town, according to George Monbiot. He's like, he's saying if that ever really gets going, and things will be made very cleanly, then I understand once they get it. So we're going to kind of have to adjust over and over and over, I think, to things as we go along.
Yeah.
Okay, I hope I made sense.
Yes, you did. Thank you. And some people said they love leaves on a pizza. I love basil on a pizza. Yeah. Go ahead, Brittany.
In terms of the foods to kind of seek out for veganism, I get you don't get like too specific, you're like just vegan, and that's just the baseline. But I always think like pasta, it's like, should we look towards the foods that we all originally ate as ancestors, or should we, since we scattered across the planet try to adapt and keep going and just build off of that.
Yeah. Yeah. Do we return back to Africa, all of us? And they'll say, wait a minute, we can't handle all of you right now. I mean, food. I'm just amazed at how food habits change so fast. Like in Africa, I was visiting Ghana, and people no longer eat the fruits that grow in abundance there. The fruits are just falling on your heads, and people are not bothering with it because they were taught in schools to eat a certain way. And so breakfast is rice and milk, which is what they were given. And so now they're looking for rice and milk for breakfast. And it's so we get ingrained into habits that are not necessarily good for us over time. And especially schools, and I think in Ghana they have boarding schools, and they have boarding schools because they wanted to integrate all the tribes, and Ghana has been very successful that way, that there is very little intertribal rivalry because the kids get to know each other as kids. But the minus point of that is that they get taught to eat a certain way, which is not necessarily good for them. Right? So when I went to Ghana, I had plenty of fruits to eat. I can tell you that. Mangoes and papayas are falling on your heads all the time.
When I was reading about the deforestation, because I'm really focusing on that, because that's like probably the biggest for environmentalism. Well, in terms of like being the first for like noticeable bad, and it was I was looking at the palm oil part. It seems like a lot of it might have to do with supply rather than demand, because places like Borneo have like an immense amount of biodiversity and nutrition that most of the world would envy, but they do palm oil, and it's because at the world stage they could just easily transport it, even though it's probably one of the most unhealthy of foods that we could find. So it's that's why they're like in the US they just keep pushing the dairy and animal agriculture, because it's something that people will try to, well, worldwide they'll say you can't farm on on land that's not arable, so then they'll say this is what we can use livestock for, so then the supply gets created to push the demand, so the marketing and everything, because people aren't normally going to be drinking cow's milk, but then you had the got milk commercials because they were growing all the cows, because it's just easy to just grow like one food rather than a whole lot of different foods. I guess according to the carnists, they're like they like simplicity sometimes, some of them. So it's like with veganism, it seems a little too complicated with too much biodiversity. That's too hard to figure out. Then again, palm oil, same thing, and that's a plant. So it seems like with the supply, if it gets too complicated, they're just not going to push for it. They're going to push for something that is simple and easy, that doesn't require much thought, that they can mass produce. And as long as the population, as the population grows, you're going to need to have something even easier to grow and faster and deliver a lot of nutrients in a short period of time. That's how you end up with a lot of these foods that could be shipped and is shelf stable rather than something that makes sense for our health and the environment. So
Yeah.
it's not just Borneo or the US, it's also Africa too.
Yeah.
Yeah. So, that's kind of what happens.
Yeah,
And I
it's
think
basically you're right. Go ahead, Brittany. Sorry, I cut you off.
oh no, I was done.
Yeah, you're right about supply and demand, and it is. Um, uh, I mean, West Africa to me it's a very rich country. Ghana is a very rich country. I told them that you're a very rich country. They said, what? You're so poor. I said, no, you have so much soil that's fertile. Just drop a seed and it grows. Okay. Whereas in other places you have to pour all kinds of chemicals to make it grow. So it's a very rich country. The same with in Borneo. It's very productive, right, to grow things there and ship it all over the place. Now, if you switch from palm oil to some other kind of oil, you're actually going to increase the amount of land you need to grow that same amount of oil. Okay, this is why palm oil is popular, because it's the cheapest oil. It's the one that has the densest production possible. So the only way to get rid of all that deforestation for palm oil is to not use oil. Is to cut down on your consumption of oil, as much as possible.
Well, you could do sunflower oil because that tends to be grown in places that are not as biodiverse, even if it uses a little bit more land. What's a little more land if you're growing in, say, a desert or something like that, versus a rainforest where small amount of land is very precious. Actually, it's kind of funny we talked about palm oil because it's Ghana, West Africa, where palm oil came from. So it's like because in West Africa they took they took the palm oil and just like deforested a lot just to do that mass production of palm oil. That's why because they do the monoculturing, they took that idea and spread it to like places like Borneo. And so that's why especially you're going to see just like monoculturing ideas where it's like just rice, just milk. Well, rice, it comes from that area. It's native to there, the African rice. So I understand the rice. I can imagine. I'm not sure
milk,
about like the milk.
I mean,
but yeah.
Milk. I mean, most of them cannot even digest it properly. Right? They're all lactose intolerant. They know it too, but they think it's part of life. Those pains that they have and the indigestion they have is part of life.
Yeah, it goes back to the context where it's like fighting against nature, even with ourselves, if it's not the environment. I did have another question, if that's okay.
Sure.
So I was wondering how come, there's something called sick building syndrome. I kind of wonder why it's not really discussed much in these climate change discussions with the rising CO2 levels, because you only need, the issues start with sick building syndrome start at like 700 parts per million, not even that far from that. So, but people don't even talk about that. They talk about the environmental issues. And I think it gets lost in translation for, where people are like, oh, it's the environment. They don't even think about themselves. So it loses the context for nature. Do you know why it's not brought up much?
I don't know. I guess, they are attributed to poor indoor air quality, indoor air circulation issues.
Yeah, but then it's like the whole planet. We take that as a single room and then apply it there. That's like, maybe it's so advanced of a concept people don't think of. But do you have any ideas about it?
I don't. I haven't really looked at that.
I could send you info on it if you want.
Sure.
Cool.
Thank you.
That's all I had to say on that. Well, unless I could talk about it if you don't know much about it. So, with occupation, I took an occupational safety class, and they talked about sick building syndrome, where the CO2 would rise, and you need to have a certain level in order for it to be safe. And I think there's federal laws that cap it at a certain amount. I believe it starts to be around 700 parts per million, but it's been like many years since I took the class. And so once you start to get, I think at 800 you start to get effects, but it's not like as pronounced as I think 900 to 1,200 or 1,800 is like the most severe something, if I remember correctly. So the thing about a building is that you can bring the CO2 out there, but when the building becomes our planet, it's like, where are you going to put the CO2 if it starts to like be suffocating? So it's like we're treating kind of you know, the place like a room, thinking it's like a building, when a building, it's not a building. Yeah.
Right,
Yeah.
right. That's a good point. There are some people who argue that you have to keep increasing CO2 because it's better for the plants. And I'm saying, no, we are adapted to where we are, and you cannot just change conditions drastically and expect life to thrive. Because life and the environment go together, they evolve together.
I think you might be right that overly domesticating of ourselves with buildings and everything might have gotten us to get disconnected from nature. So I'm putting the pieces together. Thanks.
Sure thing. Any other questions? We covered a lot today. If we keep doing this, we'll solve the world's problems, won't we? No other questions. Thank you very much for an illuminating discussion.
Thank you, Dr. Rao.
Wait, I think, did you answer in the chat the new food plan question?
The new food plan.
Yeah.
I was hoping I didn't have to look at that at all, because it's so blatantly anti-science. It's just ridiculous. I'm going to post on my next newsletter the proposed food pyramid from the USDA and the food pyramid from Marlene and Bill's Human Ecology Project. And say, this is the correct pyramid, this is not the correct pyramid. It's what happens when you let industry drive policy like that. Go ahead, BJ. You had a comment on that?
Yeah, I did. There was a meme today on Facebook where they showed that mess of all the foods, and somebody had taken a Sharpie and had blacked out all the meat and whatever is in that left corner there. And I think the only thing left was butter. And I said, okay, as long as that's plant-based butter, I said, we'll go with what's left, But it was kind of funny to see that. It's like, okay, here's the new food pyramid. Just take this part out. We'll be okay.
Yeah. I mean, it's tragic because if they implement that in schools, it's going to cause a lot more diseases and deaths among Americans. And so there are real lives being impacted by that. I wish people would look into it. Now the system is just disintegrating and it's becoming impossible to trust anymore. So I think you need that kind of shaking on the other side for people to realize that there's a better way, which is the opposite of what they're telling us. Thank you very much again.
Bye-bye.
Bye.
The house is burning, but we're still sitting in the glow. Phones charged, lights on, pretending we don't know. But the forest is silent, the river's running low, and the flame on our plates is the strongest fire we throw. Put out the fire, put out the fire. Echoes and rise, this is your hour. 7 boundaries broken, the earth pushed past the line. Climate, land, species, fresh water, chemicals, nutrients, oceans in decline. Not danger, disaster in real time. Put out the fire, ooh, put out the fire. Metafoodians rise, this is your power. And here in India, one truth stands the same. Milk is not just milk, dairy feeds the flame. Cows and methane, fields and forests turn to grain. Politics, culture, carbon, all wired to the same chain. Every cup of curd is heat in the air, every block of butter is a forest repair. It's not a small habit, it's a planetary affair. Put out the fire, put out the fire. Echoes and rise, this is our hour. Energy fixes half the hurt, Dr. Rao made that clear. But food fixes the other half, the half that's burning here. Change the plate, change the land, change the future's atmosphere. Put out the fire, put out the fire. Metafoodians unite, this is your choir. Every millet, every fruit, every sapseed, every bean is water on the wildfire of a world we've never seen. Every oil-free bite is a river turning clean. This is not perfection, it's direction. Not pressure, but protection. A week of choices can cool a generation. A company's courage can ignite a nation. Put out the fire, ooh, put out the fire. Echoes and rise, this is your hour. Metafoodians unite, Metafoodians ignite, sharing love in the metazone, light in the path to a cooler home. Put out the fire, ooh, put out the fire. Together we rise, together we inspire.